Thank you for viewing Micro X-ray fluorescence systems, adding Micro XRF to the Scanning Electron Microscope. Why use XRF inside the Scanning Electron Microscope? Technique advantages. Micro XRF offers better sensitivities at energies above 2 kV. Micro XRF offers a very low background, which gives an improved signal-to-noise ratio or peak-to-background ratio compared to traditional EDS systems. With Micro XRF, we can run at 35 to 50 kV. This allows us to excite the higher energy lines. Combine your light element EDS analysis with the heavier elements from your Micro XRF units, all in one single application. By combining these two technologies, we can perform EDS and XRF at the same exact sample location without ever moving your sample. XRF is 100% non-destructive and has no charging effect on your samples. Let's discuss instrumentation advantages. SEMs provide a very high vacuum compared to benchtop XRF. This is an ideal environment for light element X-rays to travel in. Almost all EDS systems have a light element detector. This is a great complement for XRF. With benchtop XRF, your X-ray source is in a fixed position, your sample is in a fixed position, and your detector is in a fixed position. Inside the SEM, we can move the sample up and down, we can tilt it, we can move the source in and out to increase or decrease the spot size, and we have some functionality about moving the detector as well. With floor space cost being at a premium, adding an X-ray tube to an electron microscope creates no additional floor space or footprint. Micro XRF on the SEM uses your existing detector, your existing EDS electronics, and your existing acquisition software to acquire the Micro XRF spectrum. A Micro XRF source addition to your electron microscope is less expensive than a separate Micro XRF unit, nearly half the cost of a second XRF unit. In today's world, we see electronics getting smaller and smaller. This is true for X-ray tubes as well. In the past, large tubes with cooling sources and just their sheer size made it impractical to add one to an electron microscope. Here we have the flex beam. Let's take a closer look. The flex beam incorporates polycapillary optics to focus down to 10 microns. The tube comes as a 40 micron, a 20 micron, or 10 micron focused at the smallest spot. As the tube is moved in and out, the beam can become much, much larger, as much as 25 millimeters or larger if needed. It has a cooling fan, a heat sink. This is for the optic alignment. This is done at the factory. We have the SEM interface, which is actually a series of adapters with multiple O-rings. Here we have the polycapillary focusing optic. We provide multiple vacuum sensors. That way it's highly unlikely that they both fail at the exact same time. The shutter assembly extends the life of the X-ray tube. This allows the tube to stay on without having to go through an up and down ramp every time the tube is shut on and off. It can stay on while the SEM is vented. The slide assembly is just that. It allows the tube to be moved in and out. Use the adjustment knob to move the tube in and out, increasing or decreasing the spot size. There is a built-in temperature sensor that automatically shuts the tube off if it ever becomes overheated. Here are the flex beam specifications. At 50 watts, it can run as high as 50 kV and 1 milliamp. Let's take a look at the XR series. This is a collimated system, and we call it a collimated advantage because It's more sensitive than a polycap in excitations above 12 to 18 kV. And it's a little more economical priced than a polycapillary system. It has a high voltage block, an SEM interface. This is the source. A small collimator screws on here. The two vacuum sensors. A slide stop. And an adjustment knob to vary the spot size. Here are the specifications for the XR series. The XR series runs at 10 to 40 kV. Collimators are screwed onto the end to vary the spot size and house the transmission filters. Spot sizes can be around 200 microns right at the sample surface up to 25 millimeters to make a very large bulk analysis. Now let's take a look at how these two X-ray sources are implemented on the scanning electron microscope. Here we have the flex beam mounted on a scanning electron microscope. Any EDS detector will work, and as long as we have an available open port with the right angle, it can be implemented. Next we have the XR series mounted on a scanning electron microscope, and again, any EDS system can be used with this. We've installed X-ray sources on all the SEM manufacturers. I began developing adding XRF to the SEM in 2003. It wasn't until 2004 until we actually installed them. Once installed on your scanning electron microscope, nothing interferes with the basic SEM operation. Any EDS system can be used to collect the X-rays from your Micro XRF source. Now let's begin talking about the application itself. Here we have our source. Any EDS detector. Electron beam excitation can typically excite elements down to about 0.1%. Of course, you can see elements a little bit lower, but as a textbook rule, it's about 0.1%, depending on the element. With Micro XRF excitation, we can see pretty much all the traces down to about 10 to 5 ppm, depending on which element. Let's dive deeper into the applications. The electron beam has much better excitation efficiency below 2 kV. This is ideal for light element excitation. Here is the previous EDS spectrum. Here is the same sample with Micro XRF excitation inside the SEM. This is the NIST 610 glass standard. In the previous spectrum, we showed that electron beam excitation is much better for elements below 2 kV, where in this view, we have Micro XRF showing much better excitation for elements above 2 kV. So this is a fantastic complement. From July 1st, 2006, new electrical and electronic equipment placed on the market in the European Union shall not contain substances known to be harmful to humans and animal life. The maximum concentration values are 0.1 by weight, or 1,000 ppm, in homogeneous materials for lead, mercury, hexavalent chromium, polybrominated biphenyls, and polybrominated diphenyl esters. For cadmium, the acceptable level is 0.01 weight percent, or 100 ppm. These limits will apply to all components within the equipment unless otherwise exempt. With Micro XRF, we have a much improved signal-to-noise ratio, or peak-to-background ratio, over a standard EDS excitation. Here is the EDS spectrum for the BCR standard. This BCR standard is a standard for the regulation on hazardous substances. Let's take a closer look at the BCR standard. Once again, we see an improved signal-to-noise ratio. Here's the same standard, but now with Micro XRF excitation. Here is the EDS spectrum from the standard. The certified values for the two spectra that we're looking at has lead at 120 ppm, bromine at 800 ppm, chromium at 110 ppm, and mercury at 25 ppm, easily detected by Micro XRF. With Micro XRF, we're no longer limited to the lower energy lines. Here are the overlapped lines, the moly L lines, and the lead M lines. But now we have the XRF spectrum with Micro XRF inside the SEM. Here, the lead L lines and the moly K lines can be used, making a much simpler deconvolution of the two elements. Now let's talk about combining the two technologies. This is accomplished by turning on the electron beam up to around 3 kV and the XRF at 50 kV. By leaving the electron beam on, we excite just the lighter elements. We don't get much signal below 2 kV that we can use from XRF anyway. So by leaving both beams on, we can collect the E-beam data up to 3 kV, the XRF data up to 50 kV into one single spectrum. When we talk about instrumentation combined, the system uses a common detector, your EDS electronics, and acquisition software to acquire the spectrum. We can use any EDS system. The spectrum is acquired, then exported out of your EDS system and imported into our software. We have a variety of software options that process and quantitate your spectrum. To put an X-ray source on your electron microscope, we need a port that will allow us to come in at about 33 degrees. This is typically considered an EDS port or a high angle port. Over time, we won the confidence of all the SEM vendors. Not just anybody can put something on their microscope, which is actually now your microscope. In the past, we've put X-ray sources on Joule, Hitachi, Zeiss, FEI, and TestScan. This concludes our video on adding XRF to the Scanning Electron Microscope. I hope you've enjoyed the video. Please visit us at uxrf.net.